One of the owners of Pro Controls. Our primary focus is building automation, and we're pretty excited about that, especially these days with the rising cost of energy and the way things are going. We're able to have a more of an impact in our territory to save energy and to help the efforts to build better buildings and smarter buildings. And kind of the fun part about it is to work with technology that's advancing pretty quickly and offering new ideas and concepts and actually getting to play in the sandbox with those ideas and tools and controls. I've brought a few little trinkets with us today that we'll share with you a little bit later on. There we go. So we can go over that stuff a little bit later on, and basically have a little bit of fun talking about some of the things that we do on a daily basis. So one of the first things I wanted to just to give you an overview. Building automation is using computerized and intelligent controls to operate buildings, primarily in the mechanical sense. So we're working with heating and air conditioning systems, but more recently we're integrating that same technology into lighting, security, fire and life safety, and we're actually tying all those in together. And what a lot of people kind of talk about that as being an enterprise-wide system. So the typical conventional idea of a programmable thermostat, which we don't even really have one in here, just a conventional thermostat over there. That idea of a programmable thermostat and the concept that the building automation system simply replaces a programmable thermostat is we're way beyond that. That's been abandoned, that concept and idea. We do that of a programmable thermostat times a million on a daily basis with the technology. And we're actually going to go and take you to some of our sites today over the internet to view them and look at them and see some of the programming that we do and sequences that we offer our customers to save energy and to keep their buildings in a healthy, comfortable way, keeping the employees productive and all that stuff. Feeling this isn't very comfortable. It's actually kind of hot in here today. So hopefully we'll get that squared away. The other aspect of integration is card access or access control. Buildings are asking for this. Building owners and builders are asking for this a lot more. And we're one of the area's leading access control contractors as well. So your proximity card that you carry in your pocket to allow you to get in through locked doors can actually do a whole lot more now. We have some sites that when the customer employees swipe their card to get into their office, it can turn on the lights, bring on the HVAC system to an occupied setting, ventilation up to a more suitable level for a person's occupancy. We actually employ barcoding on the access card itself, so when they go to the lunchroom, they can swipe their card into the cash register and debits their account for whatever they've purchased that day. So the technologies are merging, on a fast, greater scale than we've seen in the past years. Things are happening very, very quickly, and some of the things we kind of stumble into. Other things, technology that we're a representative for KMC Controls. They've just employed a new lighting panel, and that communicates with the building automation system seamlessly. So when a manufacturer brings us a technology, we take that to market and try to educate our customers or engineers, how to develop that product into a job. Other times, people bring us the technology and say, hey, we have an idea, will this work? And we'll actually develop a job and a project to employ, whatever different technologies are available. So it's actually fun. It's a huge industry, and we find it very, very pleasurable. One of the things I wanted to show you today to lead off is a demonstration. It's actually a sales presentation from the company that we represent. Pro Controls is an authorized representative of KMC Controls. They're a manufacturer much like Johnson or Honeywell. They just build the widgets, and we go out and install them. And one of the things that they offer us is a sales tool that we can use. They build PowerPoint presentations and so forth, and they came up with this one tool that it's a case study for a project that we were very, very loosely involved with, just, you know, from the idea of watching it take place from some customers in Florida. Now, I'm not selling you anything, so you don't have to sign up. There's nothing to sign up. But the project itself was a huge success and kind of, you know, exemplifies what we do on a daily basis. I get that. And John Marshall is a friend of mine. He's one of the leaders of KMC Controls, and I don't want to take his credit. This is his presentation, so I've left it in its original form so you can get the benefit of you know, of what really took place here. This was a case study that, and this is very, very recent. This is actually just in the final completion of validation. This case study was in energy conservation. This woman who works for a school district, Pearl, down in Florida, she was interested in saving energy in her whole school district. It's a rather large school district. If you're from New Hampshire, your school districts, you kind of think on a smaller scale. School districts could be 10 or 15 schools. Down in Florida, they could be, you know, 50 or 60 schools, if not even a lot more. And the schools down in Florida lease large numbers of the portable modular classrooms because they're growing so fast down there. The population's exploding, and there's a lot of children. So Pearl was looking for a way to save energy in all these portable classrooms. So she contacted Bruce. Bruce is an expert with KMC Controls. Bruce works for a company just like ours, although he's a little bit bigger than we are, down in Florida. And Pearl identified 12 modular classroom buildings that she wanted to target for you know, a proposal to save some energy. So what they did is together they developed a project to remove the existing programmable thermostats. Now, they already had programmable thermostats with schedules that worked and everything for the heating and air conditioning, and mostly just air conditioning in Florida. But these programmable thermostats more or less function like a kitchen timer and a meat thermometer. Not hugely accurate, and you know, not going to accomplish a whole heck of a lot there. So together with Bruce, they installed some building automation controls. And this isn't a KMC presentation. This wouldn't matter whether they were Johnson or Honeywell controls. The idea is that they put in a building automation system into the 12 modular classroom buildings. And in Pearl, once it was completed, she estimated that the project showed a return in 12 to 18 months of almost $10,000. So she got a little bit excited about that. And analyzing the data, they came to the conclusion that the building automation system was actually saving them about 40% of their electric bill consistently. So they became more and more excited about this, these facts as they were analyzing them. Looking at the actual savings, you know, based on what real numbers are, in the Northeast here, we're probably, what, around 10, 11 cents a kW, 12 cents?
Well, I don't know what it is commercial. Residential's around 14.
Okay, I think the commercials probably, it depends on who you have and what contracts, but they're probably closer down into the 12 cents a kW. Looking at this little project, though, you know, there's the payback is potentially, you know, around less than 4 months. In fact, down in Florida, the payback ended up being 6 months to pay for the project for the 12 classrooms. So Pearl got pretty excited about that and wrote a second proposal to install the same system and with the same features in quite a few more in classrooms, portable classrooms. The proposal impressed the school district, and they approved it, and they moved forward. Whoops. And they actually brought this to 4,300 portable classrooms in this one school district. So and if you can picture this, I know it's hard. I've actually been down there to see this, but it's hard to envision over 4,000 portable classrooms in a school district, but they're there, believe it. But the bottom line is the school district is saving $7 million a year in energy savings just in the portable classrooms with this one project. And these weren't, buildings, big buildings with complex systems. I mean, they're just portable classrooms with, in many cases, if you're familiar with the stand-up air conditioning units, they're almost like a window air conditioner, but vertical and mounted to the wall. In many cases, that's all they had. They actually did a little bit more with lighting, adding a little bit of lighting to the system as well. In addition to the electrical savings, they had a 35% reduction in maintenance, on the HVAC equipment because their run times were reduced. They have less air filter changes. The equipment wear and tear has been reduced. So they're basically operating what they have in the most efficient way. Since that project was developed and implemented, the software engineers at KMC Controls have delved into the success of this project to develop even better algorithms and controls and sequences. And they've adapted or employed a learning program. So they're actually taking motion detectors in the classrooms, and in addition to a regular schedule, they're taking the information of the light in the classroom and the occupancy of the classroom and having that further the occupancy schedule over time to bring the lights on only when necessary, to bring the HVAC system on only when people are in the classroom. And the different usages of those classrooms are learned by the system and adapted over time. So the programming is we're just starting to see the building automation industry actually being able to take the step from a conventional schedule of 6 a.m. to 9 p.m. we're occupied. That was the initial part of what programmable thermostats did. In building automation, we've for years done optimum stop-start, where we actually look at the temperature change in the classroom and just do a simple math formula to come up with let's start a half hour earlier to get the classroom down to temperature or up to temperature on time, and basically turn the system unoccupied earlier in the day to let it coast to save a little bit more energy. We've even gone beyond that, and we're actually having systems learn how you're using a facility to be able to further refine the sequences.
Are you monitoring, do you have a system yet where you can monitor the light levels and actually have the lights come off and on as, like, if it's a bright sunny day, there'll be lights?
Yes. Yep, absolutely. Yes. Yep. And in addition to that, yes, they're absolutely doing that. We've seen buildings, with lighting projects, they're actually taking, older fixtures and modifying them with controls, with the lighting controls. So if you had a 4-light fluorescent fixture, we'll take two of the 4 lights and put it on a separate circuit. So and a circuit that's a smart circuit where we can control it. So we can look at the light levels in the area and further refine the lighting offered. So they've taken this process and dealers in big cities are providing the solution to classrooms and areas throughout the country. They're connecting all the systems via their local networks or wide area networks, and they're making a web-based control system that's taking whole school districts and campuses and being able to operate them efficiently from one central location. Even getting more savings. Or you can actually, in some areas, because you brought up one of the good points this morning when we were discussing, if there's already a system, for example, you have a system across the street in the other building that's a different control system manufacturer than what's going to be proposed for this building, there's ways of actually partnering those two systems together now. So you can take an energy management system with protocols that are available today and have them work together as an end user, to have an actual enterprise-wide system that functions and operates seamlessly. Another beauty of the type of system that we're discussing here, the building automation system, beyond a programmable thermostat, you can actually modify the system as sequences, new ideas or concepts come up. They can just be changed and modified to stay current. Whereas a programmable thermostat, obviously, that's not going to happen. So for each investment in, whoops, for each investment in a building automation system versus your programmable kitchen timer solution, in this particular application, we're saving 24,000 pounds of coal and reducing, 44,000 pounds of CO2 emissions and saving $1,752 per building in energy costs, plus 40% reduced runtime on the HVAC equipment, saving further maintenance costs. And a little bit of just data, 36% of the nation's schools use the portable classrooms. So this one case study that was done, with KMC Controls and a building automation contractor, much like us, this has saved a significant amount of energy. It's gotten a lot of people's attention, and it particularly really piqued my interest when I first saw this, when it was presented to me, because, the first thing I thought of is, wow, I wonder what opportunities exist right in my own territory, even though we don't have portable classrooms widely used. I mean, they're widely used, but not to the degree that they are in Florida. There's potential for some savings there. But more importantly, pretty much any building that doesn't have a building automation system is a candidate for this type of project. So, and that's pretty much the end of this presentation. So I wanted to show you that primarily just to kind of give you the impact of what a building automation system can mean, to a school district or to our industry. It's a changing technology that's really advancing quickly and allowing us to make some huge impacts in cost and energy savings.
Question now, because I've installed, you've been talking about the other guy,
Mm-hmm.
the same thing. Most of these systems seem to be geared strictly industrial, commercial. Does anybody do home systems?
Oh, yes.
Want to automate a home?
Absolutely. We do quite a few smart homes. That's a little bit of a, it isn't. I have one site that I can show you. I plan on showing you today. Some of the homes that typically will be a candidate for a building automation system would be a really big home that has a lot of systems, a lot of mechanical systems. We have one house out at the seacoast that's approximately 25,000 square feet. Very large home, and it's an estate. And there's just so much mechanical equipment, we would consider that a commercial application, even though it is a residence. It is commercial. So that would be one example. Another one is a smaller house that we just did a geothermal project for. A mechanical contractor sold a geothermal system in, and they decided they wanted to, rather than just replace their existing heating and air conditioning, well, it was mostly just heating equipment in the house, they wanted to keep the existing equipment and add the geothermal system, and then add the controls necessary to be able to switch back and forth between the two, depending on what the cost of electricity is versus what the cost of LP is. Their existing, equipment was, he was heating the house with LP. This is just your average, run-of-the-mill, probably 3,200 square foot, 4-bedroom home. So we do absolutely do that.
Does that system know when to switch over itself? Does it do cost analysis on the cost of operating?
Yes, it does. In fact, I'll show you what we did is we got kind of crazy with this. We actually put a screen up for the owner to be able to just type in the cost of electricity and the cost of his current cost of LP, and the system will take it from there. It also, calculates the cost of the savings having been on one system versus the other. So, and it's in programming in the building automation industry. It's just, if you can think it, we can program it.
There's so many ways you can go.
Oh, absolutely. It is. Yeah.
So I'm thinking about the controls. We're all doing commercial audits
Mm-hmm.
this semester, and the building I'm doing is very old, and it has some basic things that need to be done before, from what I have learned.
Mm-hmm.
Before I would consider approaching the town people about doing a control system. I mean, insulating the building, insulating the pipes carrying the hot water for the heating system.
Mhm.
Where does this fit into a project like that? Where you're retrofitting almost everything. They've worked on lights, they've done a little insulation,
Yep.
but
That's an excellent question. We actually do quite a few projects similar to what you're describing, where we'll be called into an existing facility. It may be a real old mill building or an old town building, school or whatnot. And basically, if a customer has a finite amount of money to spend, they want to spend their money wisely with and basically pick off the lowest hanging fruit first to get the most value for their dollar spent. If the building's not insulated, certainly I would concede that insulating the building may be the wisest first choice versus employing a building automation system. However, it's important to really look at the overall goal of the project because a building automation is adaptable and can accomplish something today and then it can be reprogrammed to accomplish something either wholly different or slightly different tomorrow. So whenever a building automation system is installed, it has the potential to be of value to the customer. And we typically don't approach a project. We have the common sense approach from just contractors that if your building's not insulated, geez, you might want to think about doing that first. But even if it's not insulated, the building automation system is going to add value and savings from day one, whether it's insulated or not. If you're not operating the HVAC equipment to occupied levels, when there's people aren't in the building, then you're going to be saving energy at any time. So most often when we look at projects, we're doing one out in Hancock, New Hampshire. It's a really historic old mill buildings, Cheshire Mills. And it's just the most basic system. They're revitalizing these buildings and refurbishing them a little bit at a time, and we'll go in there and install a building automation system. I don't think we're connected to that site now. I won't be able to show it to you, but just the most basic ability to have, and they're renting the spaces out, so we give the owner the ability to schedule each individual zone separately based on their particular needs, and to be able to control it and manage the temperatures in those buildings with very basic systems. I think they just have cabinet unit type fan coils, just basic heat. They've developed the system so that down the road they're going to add air conditioning. That'll be a next step with chilled water. So they bought 4 pipe fan coil units so they can just add the chilled water component later. But they were wise enough to make the choice to employ the building automation system right out of the gate. So that's actually going into the building as they're doing the renovations and insulating and refurbishing. And I think that they're doing that wisely because they know they're going to be building. They're looking at their long-term goal of what they want to achieve. And as the building comes further along, it's coming further along being the most efficient that it can be. So we're doing well with that. The building automation, the functionality, as I said, is going into more and more technologies. We're employing access control and integrating that to the building automation. And when I say integration, there's a couple of definitions of that. There's one definition of the word, but it's used differently in our industry. When we typically think integration, we think that in a building like this, if you dropped a York rooftop unit on the roof and you had a dissimilar building automation system, an integration to us is being able to make the two systems talk together on a communication level. Most people will look at that integration as if we can start and stop that, we've integrated to the unit, basically just with a command to start and stop. So on the card access control, that integration can be on several levels as well. There's a few open protocols that are being adopted or have been adopted by the building automation industry, BACnet and LawnWorks. Those are the 2 protocols that we see most often. There's a few others that are starting to gain a little bit of popularity. but the prominent ones are BACnet and lawn. We'll go into probably those a little bit later on. I wanted to pretty much just give you the idea that that integration can definitely be on a communication level. So right now there are a few access control products that are either lawn or BACnet. So it can be, from a programmer standpoint, it can be as simple as actually running your software on one platform and sharing that information from one software program to several different controllers. So if somebody swipes their card, we'll look at that signal that Mary has just entered the room, and what do we do when Mary comes in, and we can actually write software to handle that accordingly. So that integration is what we're really after, and that's where the building automation whole industry is going with a full integration. So we'll go into the open protocols afterwards and how that all happens. One of the things I was hoping to do is probably try to give you, and this might be of interest to you in particular, is to take you through the whole process of building automation cycle, sales cycle, down to installation and startup and so forth. Would that be kind of an interest to you? See how this whole thing comes together? You may have, I'm sure you've probably been more involved in it. Do any of you work in the building trades? You do? What do you do in the?
I work for the airport for facility operations.
Okay.
We use John.
Manchester Airport?
Yep.
Oh, okay. Well, we have a system at the, we take care of the air traffic control tower.
Yep.
Do you work with Bill Gates?
What's up?
Do you work with Bill Gates?
Negative.
Oh, no?
The FAA does all the,
Yeah.
all the tower stuff. So.
Yeah. Oh, yeah, it's not the Bill Gates.
Yeah.
It's a different one. So, interesting. That's a unique project. We've had a lot of fun with that one.
Yeah.
That's exciting. Well, basically, in the building automation industry, what's happening now is right at the design and concept level of a project, whether it's a renovation or a new building, the architects get together with a building owner and may actually invite in a mechanical engineer at that time to actually start developing the design of a facility. The building automation system actually starts to have some ideas, some concept right at that very beginning. How big is the building going to be? What's the usage going to be of the building? And so the architect, probably doesn't think building automation at that moment in time to a large degree, but I'm sure in some of your other aspects of what other people are going over, they are more. They're looking at the lighting. They're looking at some of these technologies that can actually work together instead of just being totally separate. They'll spend a little bit more time. What we're seeing in practical application, they're spending a little bit more time with the mechanical engineer, kind of coming up with some ideas on how things are going to work together. I'm not going to talk about their trades a whole lot because that's, I'm not really an authority with their businesses. But once the building is designed, the mechanical engineer has they've determined how they want this facility to operate. They'll come out with some drawings, and the mechanical engineer will define a specification along with all the mechanical systems that are going to operate this building. From that specification, they'll decide what type of a building automation system is going to be used. Is it going to be a real high-end to have a lot of bells and whistles and a lot of potential savings and really tight operation, or is it going to be a basic system that can be added onto over time? All those questions get answered at the spec, and honestly, it's mostly driven by cost, what the owner has to spend and trying to get the most value for their energy dollar or installation dollar. We look at the project when it comes out to bid, if it's a plan and spec project, or if it's in the design phase, we'll actually be contacted at the design phase to work with the mechanical engineer and design the building automation system to go into it. Those are the two most common ways that things happen around here, either plan and spec or design build. Probably, definitely more than half of the projects are plan and spec, for us. Working in the plan and spec world, it's basically competitive bid. The engineer has designed something and said, I want it to accomplish ABC, and we take their specification and try to find the most economical way to meet that specification and build the project. Put a number on it, put our bid in, and hope for the best. When we get the project, as usually is hopefully what happens, we take it at that point and start a submittal process. So we've been awarded the job. We'll actually take an application engineer in-house, sit down with all of the contract documents, the electrical drawings, the mechanical drawings, specifications, and review it all at length and design a whole project, from start to finish, including schematics for the whole project. I grabbed one. We're doing a school up in Bethlehem. So this design phase will yield what's called a submittal. This submittal is going to include a lot of stuff. It's going to have the sequence of operation of all the mechanical equipment, which may include lighting. It may include other technologies, access control. I don't believe it did on this project, but the sequence of operation defines exactly how the building is going to operate and how each piece of mechanical equipment integrates into the facility and provides the necessary energy management and comfort into the facility. The next part of it is the products that we're going to use to make this all happen. We have hot water valves, chill water valves, control dampers, and those all get sized based on design. So that's where the application engineer in our office, earns his keep. He's going to be designing, to meet the specification, but also he's designing to make sure that it works. So we're looking at, a hot water coil that is supposed to generate, 1,000 BTUs or 5,000 BTUs. What size hot water valve and what type of valve is going to be needed to make that happen and to heat that classroom or that room that we're serving. We use different, formulas and everything to achieve those desired results. The other big aspect in most of our projects now are VFDs. We'll integrate those into our submittal as well, for pump control, air handling control. We're going to vary, rather than just turn a pump on, oftentimes we're going to vary the speed on it depending on what the need is in the building for hot water. And we also include cut sheets on all the equipment that we are going to provide on the project. That's mostly a clerical function in the office, just to pull the materials, bill of material, and then apply a cut sheet that responds to that. And then is where the real work for us begins, is all the schematics for a project. I'll hand this around. What you can look at is the, just flip through it just to get an idea. What we do is, for all the equipment that's installed or going to be installed in the building, there's going to be a control device that has to operate that equipment. And a building automation system is a networked system, so we may be able to take one DDC controller and operate several pieces of equipment. We may, they're very flexible. We may be able to, have everything in one giant control panel in one room, operate the whole facility, depending on how it's laid out. So our application engineer is going to determine that based on, what the most cost-effective method is to approach the project. There's a lot of work that goes into these submittals into this process, and this is basically the blueprint of our whole building automation system for this one project. This is the blueprint that we'll follow from our support standpoint in the office, our design, our installation out in the field, and I'm sure you've spent a lot of time with these and maybe looked at some pretty similar to that. And
Actually, the fact that you have cut sheets for everything just impressed the hell out of me, because I've never got a spec.
really,
Not once you get on the job.
oh yeah.
In the bid phase, yeah. But when you get on the job, where you could really use one of those, never have.
Well, prior to you even going out to install any of the equipment, what happens at this phase, our application engineer developed this whole product. We've reviewed it in-house, and we've determined that, hey, this is going to work. Everything should be good. Then we submit it to the mechanical engineer for review, for further review. Typically, the mechanical contractor is going to get several copies. They're going to review it. They're going to make sure that our stuff is going to work with what they're providing for mechanical equipment. And then mechanical engineer is going to spend the most time with this submittal. And, you know, it varies. You know, there's times that they'll go through it with a fine-tooth comb and you know, find small errors and want them corrected right away. That generates a resubmittal. But all this is taking place before, typically, hopefully, before the building is even broken ground. It's certainly before you're going to be out there
I
installing
like
it.
having a complete set, because I can keep a running list of changes.
Yep.
Myself. I have it. Plus, the amount of time that you save being able to look your stuff up on your own in the cut sheets, instead of calling the office going, hey, listen, I
Yep.
got a little problem, you know, this VFD, you know, the valves on this aren't, I don't think they're right.
Yep.
And so, well, the cut sheet says this, and this is what it says, and then, you know, but if I have it right there, you know, if I just have to give it to you, and then somebody's got to look it up. And sometimes, you know, especially if you, I've noticed in the time systems, you may end up not getting the answer for a day or two.
Exactly.
You know, and in that time, you're waiting, you know,
We-
50 years.
We try to put a, you know, we spend an extra effort in the office to put together a very good product. This, you know, this submittal is eventually going to turn into a maintenance manual, owner's manual for the project. So we'll take this information and add to it some installation stuff. Yeah, Wes?
That brings up a great point. What do you do to see that the system doesn't, for lack of a better term, obsolete itself? Like, for example, what I keep hearing happens is the guy who you've trained to run this system retires or is out sick for a month, and the whole thing falls apart. I'm not saying your jobs, but
Yep.
you know, that seems to be a fairly typical scenario, I think.
The building, you know, a control system that we install, our intent is to automate the system as much as possible so that it can operate the building the way it was designed and intended to be operated with as little human intervention as possible. So we don't want somebody to have to be sitting at a computer every day, you know, tweaking and adjusting to make the building work correctly. To answer that, you know, even further, I mean, certainly, you know, it requires a building automation system is a very complex, you know, system that's operating a lot of equipment. So there's the system. What we're trying to do, in addition to save energy and operate a building comfortably, we're actually have some other goals with our system. When we get into the front end with the graphics, the graphical user interface, we're trying to make this as user-friendly as possible. So to give the building operator the ability to troubleshoot mechanical equipment. So if we display a picture of an air handler on the screen, we want him to be able to look at that air handler more or less the way it's actually exists out in the field and have data points that, you know, that correspond to what's really happening out in the field. So if the command for a fan to run is on, but the status is off because there's no airflow, you can, you know, quickly deduce that, geez, maybe I have a broken belt, or, you know, somebody shut a breaker off, or, you know, something like that happened. So the systems won't, the answer your question, I think we want the systems to run as automatically as possible. And we try to make our front ends as user-friendly as possible so that if the person that has been operating the system, you know, for the past 5 years retires, somebody should be able to come in and step in and take his place with a reasonable amount of, you know, knowledge and experience to actually operate that system as well.
Great.
And that's advancing tremendously as time goes on. You know, we're actually, you know, trying to, you know, listen to our customers, what they like and what they don't like. What, you know, we kind of watch them when we do training. I do a lot of the customer training, you know, when the final system's turned over, and I'll observe how they interact with the system. And if I see them struggle with something, you know, I'll actually take the time to find out why they're struggling with it. If it's just something, you know, hiccup that they have, that may be one instance, but if it's something that could happen with everybody. For example, one of the most common points on front ends on graphics is we display a lot of data. I want to see if I can pull up a system to give you an example of this while we're talking about it. We'll display data, and some of the data is read-only, and some of it is adjustable. The biggest question is that people ask for us is well, I've tried to. it's too cold, so I'm trying to, adjust the outside air temperature. And you just can't. I mean, if we could do that, boy, we'd be in much better shape. I'd like to, especially this winter, I'd like to crank it.
Go away quick.
Let's see. I don't want to use that one. I'm going to give this one a shot.
I actually had a client ask me once to put the outside air temp in a sunny spot.
Oh, really?
Yeah. I said, why would you, well, because then it will register a higher temperature and the heat won't come on as often. I said, yeah, but the program's gonna be trying to make you comfortable.
In terms of resources, that happy profile school you had there,
Mm-hmm.
either in dollar amounts or man hours, how much effort goes into producing that document?
That's a tough one.
I only pick on that one because that's the one you had.
Yep. And that
Project to project, obviously.
exactly. That's a very typical type of a job. One of the things that we try to do, I mean, we're contractors, so we change hats often. We change hats when we're providing customer service. We want the best for our customers. When we're in the office trying to do a job, we put our contractor hat on, and we want to make the most money that we can on that project. So we try to automate our own internal processes as much as possible. So we have libraries of drawings that we can draw off of and just modify. So believe it or not, in fact, this job actually generated a lot of discussion over this. That job, that size job, the submittals can be done in anywhere between 80 hours, 80 man hours, and 300 man hours. I've talked to a few other contractors. I've worked for other contractors in the past, and there's several contractors will put more time and effort into the engineering phase, into that phase, to really, really refine a lot more information for the field installers, so that they can do a faster job out in the field. Other contractors will be a little bit looser on the schematics, put a lot less detail in there, and then and save the money in the office, and then allow for a little bit more effort out in the field. We try to balance the two. We put a lot of effort into our submittal process because we really want it to be accurate, not just for our field guys to do a better job, but because we want our customer to really have a good blueprint and schematic for years down the road. Hopefully they keep those. We actually keep them on file for every job we've ever done. So,
Hard copy?
oh yeah, hard and soft. Yep, absolutely.
Wow.
Yep, we have file cabinets full of them, and I might add that Pro Controls, we've been in business for 6 years. Just next month it'll actually be our 6 year anniversary. Thank you. And already we have a stack of filing cabinets. I think we're up to 10.
Well, I do document preservation for our business, and I'm running out of space, so.
What do you do? What's your?
We're doing renewables and energy efficiency. What I'm in school for. I didn't know how I
Excellent.
was gonna do it when I started the business, so I kind of put the cart before the horse, but it's working out.
Excellent.
I have a question.
Yep.
With like CAD files and things like that, I know like we use some over at my work. Do you do anything with that? Like, do you find those are more helpful than working with the old school blueprints or anything like that? Or if you see schematics, like having them like on a file where you
Right.
just bring them up?
We do all of our schematics are either in AutoCAD or Visio. We use both AutoCAD and Visio in our office. We standardized on AutoCAD from the beginning. I prefer AutoCAD over Visio, not because it's any better, just I'm more familiar with it. However, we had a lot of engineers that supported Visio versus AutoCAD, so we actually found ourselves kind of in a quandary of having to deal with both software packages. So I'd say nearly 100% of our work is done either on AutoCAD or Visio. We don't. We work with the mechanical drawings typically after they're printed. And most all of those are done with AutoCAD. Oftentimes they'll give us a set of the drawings electronically, and we'll just work off of those. So I'd say probably Seems like the industry is probably about 75% AutoCAD and maybe 25% Visio. And the Visio seems to lend itself fairly well to the smaller projects, small schematics and so forth. It's really not that bad. I'm seeing more and more facilities using Visio for like their, like we do some big office buildings. This is one of them. If you can see most of that on one page. Some of the bigger office buildings, what they're doing is, I forget what they call it now. They have the person that in facilities that handles their office planning and you know, furniture, all that stuff, the layouts, because they're constantly changing office buildings. So I see them using Visio more and more in those instances. It's easier to learn, I believe, than AutoCAD. So this would be a typical site that that we've done. Usually when we log into a system, and this is live, by the way, we're actually online with a facility down in Massachusetts right now that we've done. Typically a main page, we're just going to give them some basic information. You know, the building is occupied. We'll give them, you know, whatever they decide. In this particular case, the owner wanted to know what the building's static pressure was. Because of the way this building is operating, that's an important bit of information. They want to be able to keep that building slightly pressurized at all times because of some of the processes and tenants that are inside the building. So that's something that they're watching very closely. And energy savings is a big concern for this facility. This was an existing facility that we added our building automation system in. So they wanted to wring out a lot of energy dollars. Now we've just barely turned this system on. We completed the installation last week, and the front end, the graphical user interface, we actually just turned on over the weekend. So this is brand spanking new. We haven't even proofed it yet, and we haven't gone through the commissioning process yet, which is something we'll talk about a little bit later.
It's amazing. It's got a relative humidity.
And
This is your remote login, right?
this is Internet Explorer. I'm just using Internet Explorer to browse to the site. Most of the major control manufacturers are offering software packages that allow for building automation systems just to be accessible over the internet.
So would you have to go, would you have to go to the site in order to like reset like parameters and things like that, or could you do that like through?
Yep, we can do it
Like,
remotely, absolutely. There's different methods of being able to actually program the controllers. Typically, you're not going to be able to, you're not going to program the controllers via the web browser, typically. In some cases, I can. But in most of the time, we're going to use a different software package to, a technician's tool, per se, to get into the controller and actually program the controller.
There must be some security built in.
Oh, absolutely.
Yeah.
Absolutely. And that...
You could have lots of fun on April Fool's Day.
I can imagine. This would be a typical floor plan. We're gonna show the, it's all working too. This is great. It's a good day for me. We'll typically show, just a floor plan that just gives them some overview of what the room temperatures are in the spaces. So, at a glance, the building operator can look and see exactly what, if there's any glaring problems. In addition to any alarms that might happen, we display alarms right on the front end, and we can display alarms in email, pagers, cell phones.
How much control do the occupants of those rooms have on the temperatures?
As much as we want to give them. For example, we'll just grab any room here. FP VAV 22. Sometimes it's hard for us to get away from, the nomenclature that, we work in our industry. This is one of the struggles, kind of goes with what you were talking about a little bit earlier, Wes. We're building automation control contractors. We're working with mechanical engineers, and yet we're interfacing to an end user. So we're using terms that everybody else is, and then we're trying to translate that into a system that anybody can understand. So FPVAV, it's a fan-powered VAV box, and it's box number 22. It makes a lot of sense to me, but the folks on site may look at that and say, well, I don't like that. That doesn't tell me. I want that to say Mary's office. So what we'll often do is, and as I said, this site is brand new. We haven't even turned it over to the owner yet. Once we have it, in their hands, then we'll start to make some slight modifications to put some naming conventions in there that make a little bit more sense for them.
Okay, so by going into that VAV section, you can actually limit how high your loading can raise or change the temperature?
Exactly.
The temperature band?
Yep. So we'll dive into this VAV box right now,
Wow.
and
Very nice.
Is this for that room?
yes. Yep. Well, I just clicked on that room, and we're right down into the room.
This is the side of
Excuse me, would it help if I tried to make the picture larger on the,
It might. Yeah.
let me see if I can do that.
So, 2 points I want to get back to tie this in together for you. Your question, how much range do they have in their thermostat set point? Well, this is the actual room temperature, and this is the high and low limit of what we're going to allow them to adjust at the thermostat.
So what else we want, airflow, air changes, drive operating time?
Wow, 74. That sounds pretty low.
Your reheat set to 0?
Uh,
Or is that its current reading?
That's actually its current. Right now, the state reheat is disabled,
Right.
and the heating signal is 0.
I see it there, yeah. Very, I like that.
So right now, this box is in a cooling mode. Our cooling signal is 100%, and as is it should be. It's working, another good thing. Everything's happening great today. The room temperature is 69.1. The actual calculated cooling set point is 68. So we're actually trying to cool that room down to 68 right now. And you'll notice that I've labeled these. Well, see, I've got to do a little proofreading here. I chopped off my set points. I've labeled these calculated set points, and the reason why they're calculated is because the folks can go to their thermostat and make an adjustment, and the system is going to interpret that adjustment to do what we allow them to do. So then it becomes a calculated set point. And there's for most every heating cooling application, you have a cooling set point and a heating set point. We obviously don't want those to overlap, otherwise your any potential energy savings are gone if you have heat and cooling on at the same time. So we have our own internal standards of what we do, and I'm sure most building automation contractors are the same. We usually offer a 2-degree deadband between heating and cooling. That's a widely accepted, for most applications, offices, schools. That's widely accepted as a standard starting point. We'll refine that further in specific projects. We have projects that the engineer will decide that the building operator, who's maybe at a higher level than most, let's say this could be a manufacturing business, they may want to have access and control over the deadbands and other tuning parameters. You notice if I hover over the points, our front end will actually tell you what the point is. So this is a loop. This is a signal from a control loop. That control loop is actually the PID functionality of the cooling set point. You guys familiar with that at all? A little bit. Proportional integral derivative gain. It's just a mathematical kind of an algorithm to determine, to try to bring the set point, bring the room temperature to the set point, or the medium to the set point.
I missed outside temperature, and I know it had to be there someplace.
Upper left corner on all of our jobs. Right there.
Thank you.
The RTU on the left side, that actually goes to show you what rooftop unit it's
Yep.
connected to?
Yep, we can jump right over there.
The rooftop unit's performance too, right?
Yep. I didn't really want to get into this too deep at this point, but no, that's okay. I love it, so that's fine with me. Basically, when I spoke about integrations, this is an integration in its purest sense.
Oh, no, this just fascinates me. I don't want to be on the solar anymore.
This rooftop itself is I think this is a carrier. I believe this is a carrier rooftop with its own control system, and we have a KMC control system operating the building. So our building automation system is KMC, but the engineer specified BACnet as being the protocol he wanted to adopt on this project. So the folks that provided the rooftop equipment had to make sure it was BACnet compliant. Our system is BACnet compliant, so we just mated the two and integrated them, and all this information from the rooftop is based on what Carrier made available for points.
Yeah, one more question.
Why is the supply air temperature, shouldn't that be the same as the outside air? I mean, obviously it's not, so the answer is no, but why isn't
Preheats.
the supply air temperature the same as the outside? It's not taking directly from outside air.
Well,
Reclaiming some inside air?
right now, the outside air damper is 94% open. The rooftop itself is, it's idling at 36%. The VFD signal is at 36%, or I'm sorry, 32%. So the building is largely satisfied. So, you know, the rooftop's not doing a whole lot of work, and basically what little work it's doing is with the outside air dampers economizer being open right now. So we're providing 94% outside air, maybe 6% return air, mixing that to get a 64-degree discharge air temp into the space. Believe it or not, a building like this, with a lot of people, computers, and everything else in there, we'll be cooling this building most of the year rather than heat. Some areas may add some heat, and this will really make you feel good about building automation. They're heating this building with electric heat.
Where is the building?
Geothermal?
No, electric heat.
In Massachusetts?
It's in Mass, yeah.
On your floor plan, now that shows the entire floor plan for the building, or just the floor plan in relation to this particular nuclear system?
This is the whole floor plan. There's actually only one rooftop for this whole building. It's a giant rooftop, though. You know, that doesn't kind of give you the scale.
It's one, are you saying one rooftop unit for the whole entire facility?
Yes,
3 floors?
Yeah.
That's
So when that goes down, what's the backup system? Is that it, or,
that's it.
really?
Yeah, actually, it's a good question. What they actually had this rooftop designed and built for this one facility. It's actually 2 rooftops in one. It's in one enclosure, but each fan has a backup built into it.
What was
So
the reason for going with one rooftop unit, like?
this is an older building. It was probably built in the late, probably early 80s. I'm going to guess at the age of the building. And you know, we've seen over the years, you know, in Wes, you've probably seen a lot more than I have, but buildings, you know, the whole design and concepts to design has changed quite a bit. So, I mean, I've actually gone into buildings where they've put electric reheats into the rooftops, and they put them all in the return airstream. And that was by design. I actually saw it on the original prints back in the early 60s. And it, you know, they don't do it like that anymore. It's just, it's totally different. So, yeah, I'm not sure what the whole idea was on that one. That did get changed,
We
but,
were putting them in like that, we didn't understand it either.
yeah, I mean, we,
I got a couple of reds. What are those? Alarms?
yeah, no, those are, right now, those reds are what we affectionately refer to as blisters, or the measles. Those are actually VAV boxes that have probably gone offline. Right now, since we brought the building automation system online, and we're able to look at the whole system, we've discovered, you know, some problems, mechanical problems with the VAV boxes themselves. So the mechanical contractors on site, in fact, they're there today, working on some of the VAV boxes, replacing the electric heat elements. Some of these VAV boxes are fan-powered boxes. Some of the fans are burnt out, so they're fixing some of those. And we noticed that during the installation process. So they're fixing a lot of that. So I would assume, you know, if there's a few offline that, and we'll get some errors, alarms that'll come out, it's just because they're down there working on them. So if we grab a room that's a little on the cool side, this is a hallway right here. We may see one that's actually in a heating mode. Yep, and we're popping up some data here. Yeah, so the electric heat element here is going to show some signs of life. It's turning red. The electric heat is enabled. Heating signal on this particular one's 100%. I think this is one of the ones that is broken. No, it's not. They fixed it. Our supply air temperature from the VAV box into the space is 103 degrees. So that's a good indication that the electric heat is working. if, on some of these, what we discovered when we did the startup, we're trying to run the electric heat, and we have it enabled and turned on, and the discharge air temp is the same as what the air handlers, the rooftop is delivering. Pretty safe to assume that there's a problem with the electric heat. Yep. So, and then back to one of the original questions, when we design our front ends, back to what you were talking about, Wes, we try to stick with certain standards that we've developed in-house that seem to work, so we're consistent from project to project, which makes life a lot easier for our technicians when they're trying to help a customer troubleshoot a problem. It also makes our training for our in-house people a lot faster because they're used to seeing how we do things. Not that the way we do it is perfect. We're constantly evolving and finding better ways of doing what we do. But one of the standards that we've adopted is points on our graphics are either adjustable or not adjustable. So points that are not adjustable just show up as a regular point, and anything that is adjustable